Hi guys, tonight we're going to take a look at how to find an exponential regression or an equation for an exponential function on the graphing calculator. And just like a linear regression or a line or an equation for a line of best fit like y equals mx plus b, today we're going to focus on y equals a times b to the x because we are doing exponential functions. So you should have had this sheet that was passed out in class today. We are going to go through this example right here to show you how to get an equation for y equals a times b to the x, an exponential equation for this data, how to use the graphing calculator to do that. So we're going to go ahead and enter this data in our graphing calculator. Year is going to be in our list 1, and account amount is going to be in our list 2. So the following data represents the amount of money an investor has in an investment account each year for 8 years. We need to determine the average annual rate of return on the investment. So what we're looking for is what is the growth factor? What is he getting on his investment? So let's turn the calculator on and we're going to hit the Stat button. And we want to edit our list, so I'm going to hit Enter. And again, in list 1, we're going to enter the year. And in list 2, we're going to enter the account value. And when we enter the year, we're going to enter the years since 2008. So 2008 is going to be entered as 0. 2009 is going to be entered as 1. 2010 is 2. This is the years since 2008, all the way up to 7. So why are we doing that? So he put this money in his account in 2008. We want to know how much interest he's made or how much his account balance is worth after that. So the difference in years between 2008 and 2009 is 1. The difference in years between 2008 and 2010 is 2. Then we're going to go over to list 2, and now we're going to enter the amount. So in 2008, he had $20,000, then $21,225. 22,357, 23,620, 25,088, 26,482, 27,978. And finally, 20,612. And make sure to hit Enter after that. So this is very similar when we're trying to find the line of best fit. We're doing the same thing. We're entering our X list in list 1 and our Y list in list 2. So if we want to see what this data looks like, we can hit second and Y equals and make sure that this plot is on and hit Enter. And hit Enter again, we turn the plot on. And then we're going to go ahead and hit zoom 9 to see what the data looks like. And so at this point it doesn't look too curved, it kind of looks linear, but it will have a rate of return. So we're looking for what is the common ratio between 20,000, 21,225. What's the common ratio between these two? So how are we getting from one term to the next on the L list? So we viewed our graph, and this is what our scatter plot looks like. So now we want to find a curve of best fit because this is a curve. So I'm going to go back to Stat, arrow over to Calc, and then the linear regression, the line of best fit is what we did when we had linear data. This is not linear. This is exponential. So we're going to arrow all the way down to 0 and hit Enter. And I'm going to hit Enter once. You might have to hit Enter several times. So if we look at what the calculator gave us, here's our exponential equation, y equals a times b to the x. Our start is $20,018.02. It's going to round to 3 cents. And our growth factor is 1.057. We'll go to 575. So on the calculator, our start is 20,018, and on our chart, our start is 20,000. So what's the difference between these two? The calculator is putting in a curve of best fit similar to our line of best fit. So we want to put this data in our y equals to see how this equation will fit. So if we're looking for our initial term again, that's A, that's $20,018.03. We're going to round to the nearest hundredth, and our growth factor, our B, is 1.0575. So I'm going to go to my y equals, and I'm going to type that equation in. So my start is 20,018, and I believe it was in 3 cents, times, here's our growth factor, it's 1.0575, and we're going to raise that to the power of x. So now if we go ahead and graph that, there's our curve of best fit that fits on our scatter plot right there. So if I wanted to know how much money the investor would have in his account 10 years from the start, and that would be in 2018, if I hit second and graph, so this is where we started. 6 years from now, he would have $27,996, and in 10 years, he'll have $13,000. And I can keep on going. How much would he have in 15 years? $46,305 if he kept all that money in his investment account and didn't take any money out. So let's go through those steps again. Stat, enter. Here's our list 1 and our list 2. To get our A and B values, we hit stat again, arrow over to calc, and we want to go all the way down to 0 to get an exponential regression. You're going to have to hit enter probably 5 or 6 times. I just have to hit it once. This is our start, which is 20,018.03, and our growth factor is 1.0575. So how can we convert this into a percentage? So we talked about this in class on Thursday, and a little bit we talked about it in class on Wednesday. So here's my 100%. So what do I have to add to 100% or to 1 or 100% to get 1.0575? So if we take our decimal and just move it over 2 places to here, our annual rate of return would be 5.75. Okay, now it's your turn to use the exponential regression notes, the calculator notes on that green sheet of paper that you got in class today, and your calculator to answer the following questions. So you're going to use your graphing calculator, and you're going to submit your answers on the Google form that's linked on my website. The table below shows the number of bacteria cells growing in a laboratory. Here is the hours since the observation began, and here is the number of bacteria present. Use your calculator to answer the following questions, round to the nearest hundredth, for both the start and the growth factor. 1, what is the common ratio, the growth factor? B, what is the start or the initial term A according to the calculator? Because you might get a different number than this start right here. And what is the explicit y equals equation? Record these answers in your homework notebook, and then when we get through all the questions, you need to enter those questions on the Google form. Part 2. This is the number of monthly active Snapchat users from 2013 to 2016. 2013, there were 33 million users. 2014, 100 million. 2015, 180 million. And 2016, 301 million. What is the common ratio or the growth factor? So when we're entering this list, or when you're entering this list in the calculator, this goes in list 1, the years since 2013, and this goes in list 2. What is the start, the initial term, according to the calculator, and what is the explicit or the y equals equation? Last 2 questions. Use the following scenario to answer questions 7 and 8. Suppose one of your ancestors invested $500 in the year 1800 in an account paying 4% interest compounded annually. write the exponential equation where x represents the number of years and y is the total amount of money. So if we have our start right here, it's 4% interest. That's how much is increasing yearly. That's the rate of the percentage increase. You need to make sure you put the correct growth factor in there. What is in the account balance in the year 1850? And remember to represent the year 1800 as year 0 in the calculator when you're entering that in there. So in 1850, how many years after 1800 is that? And you can use that as your x. And be sure to enter your answer as dollars and cents, and to put these in the Google form that is linked on my website.